Today we're going to talk about large sample tests. Now, before I start doing the problems in this particular unit, let me first tell you some of the theory behind these topics. Now, what do you understand first by a sample? Before we start understanding what a sample is, we need to look at the theory in this unit. So firstly, let's start understanding what a population is first. Okay. Now, firstly, if you want to look at a population happens to be something which is really large in size. Okay. Now, if you want to study this, if you want to go about asking questions, it's going to take you a very, very long period of time. Instead, what you do is you take a sample of this population, which means rather than me taking the whole thing here, I end up taking a small part of this. That is, this is not going to be the entire thing I'll study. Instead, I'm going to just study this much. And when I study only this much, it makes my research so much more easier. Now, this is what you do when you do statistical large sample tests. Now, let's say, for example, I want to study I want to do a particular research in my college. Let's say I want to go about asking how many students in the college I work know this topic. That is, how many of them know large sample tests. Now, in my college, the entire population, if I were to consider the first PUC and the second PUC students put together, that comes to about 2,000 students. Okay. Now, let's say, what if I were to study the entire 2,000 students by asking them the question, how many of you know large sample tests? Now, if I were to ask the entire 2,000 students, here becomes my first problem. The first problem I have here is the entire 2,000 students here are not commerce. They are not. In fact, in the entire 2,000 students, if I were to consider, it's about 1,200 students who happen to be science, and the remaining about 800 happen to be commerce. If I were to go about asking the students here, how many of you know large sample tests, I would get a conclusion saying that the majority, or say even 60-70% of the students, do not know anything about large sample tests at all. Now, that kills my assumption. So rather than doing a research where I talk to everyone, I in fact take up a sample. So what I'm going to do here is, I have 800 students who are in fact commerce. Let me just write it down here. 800 students in fact are commerce. Now still, it's just me who's happened to be working. It's just me. So I can't go about asking all the 800 students here. Instead, what I'm going to do is, I'll take a sample of this. There are students who have mathematics in their combination and statistics in their combination. There are students who don't have statistics at all in their combination. So I'm going to exclude the students whom I don't want in this study. And the next thing I'm going to do is break down my sample size further. I'm going to go about asking only students in second PU, because these guys are the ones who are studying large sample tests. If I include first PU students in the sample, my results in fact will not be accurate. So what I'm going to do is, rather than in fact talking to all the 800, I'm going to start breaking this down. I'll start breaking this down to say 600. Okay, 600 is a little too many. Let me break it down to 300, and let me eventually bring it down to say 100. That's approximately 2 classes in my college, 100 students in 2 classes. So I would in fact talk to 100 students, and 100 students here would be my sample. I take a sample because a sample is always easier to study than in fact a population. If you were to do research, let's say you want to do a research on in a country like India, how many people would prefer to wear cotton clothes? If you look at the population of India, it happens to be 1.2 billion. And me walking around with a questionnaire and asking them how many of you want to wear cotton clothes, the research is never going to end. So instead, what I'm going to do is I'm going to take a sample, and in that sample I'm going to decide how is it that the number of people are going to fall into it, and that's when the concept of hypothesis actually begins. Now, let me go about explaining a little bit more theory. I've always told that if you know your theory well, the solving of problems in fact becomes so much more easier. So, we've understood what a population is. We've understood what a sample is. Okay. Let's look at population mean and sample mean. So population mean here refers to the average. I know mean is calculated differently, but for the sake of simplicity, I'm just going to call mean as average. Population mean is always a large number because you are looking at a population here. It always happens to be large. Instead, what I'm going to usually consider would be a sample mean. A sample mean happens to be small because a sample itself is small. Now this is in fact what the basic difference would be. Population mean is usually something we don't consider because it's not really useful for our studies because the value here happens to be large. But however, if I were to take sample mean, the value is small and it makes my calculation so much more easier. Okay, so when I go about looking at this data, I'm eventually supposed to come across a hypothesis. Now, what is the meaning of a hypothesis? A very easy way to understand a hypothesis is to look at it as an assumption. Now, in the research world, assumption is not really something that you would go about using blindly because it's not really a professional term. The more professional way of looking at an assumption would be a hypothesis. Now, let me give you an example of a research that I conducted a few years ago to understand how many people look at a product label before they go about purchasing a product. Now, my hypothesis for the research is not many people happen to read the product label. So I was under the assumption that my hypothesis here was not many. When I say not many here, I mean below 50% or 51%, in fact, don't read the product label at all. Now, this is my assumption. I am yet to, in fact, test if my assumption is right or wrong. When I do a research, when I go about collecting data, I'll be able to, in fact, prove my hypothesis or I'll be able to disprove my hypothesis. Now, it's perfectly fine if your hypothesis is wrong. And in the world of research, you don't really have to feel bad if your hypothesis is wrong. Because when it's wrong, you actually learn something more. Oh, in fact, it's the other way around. In fact, when I did this research, I was clearly under the assumption, my hypothesis was the number of people who don't read product label is in the majority. That is, I was under the impression that 51% of the people who I'm going to study, 51% of the sample, this is not in fact going to read product labels when they buy something. To my surprise, when I did the hypothesis and I actually did the research, it turned out more than 75% of the people happen to read the product label. Now, this is what I learned by doing research, and this is what you would refer to as a large sample test. I contacted around 200-300 of my classmates, of my students, and I went on to ask them a series of questions. And after doing the analysis, I saw that more than 75% actually read the product label. In that case, my hypothesis here has been rejected. I say rejected because I was under the assumption that 51% of the people don't read it. Now, after doing the research, it shows more than 75% happen to read it. So my hypothesis here happens to be rejected. If, let's assume, my research were to give another side of the data, that is, it says that just about, say, 35% of the people read the product label. In that case, what would happen is, my hypothesis turns out to be right. My hypothesis initially, if you remember, says majority of the people do not read the product label. But now here it says only 75% of them read, So 65% in fact actually don't go about reading the hypothesis. If that happens, my hypothesis actually gets accepted. My study was based on whether or not people actually read the product label, and I was under the impression that okay, people don't read it. In one case, I could actually arrive at a result saying that my hypothesis is in fact been accurate. I assumed everything correctly. In other cases, it could say I did not assume it right. So this is in fact what you would do in the whole unit here. In the next video, I'm going to talk about examples, and in that I'll explain how you use this information you see here and you come out go doing your problems. Okay, thank you for your time. I hope you guys found this video useful. And yes, I did manage to fix the autofocus. So even if I do this, all that, the camera doesn't go blurry. Do subscribe to my videos and have a nice day. Bye.